Hey GED students, it's GED question of the day time. And we've got kind of a little geometry word problem here, but it's got a trick to it. So let's check it out. It says a certain cube has a volume of 0.008 cubic meters. Now I know you guys read that as 0.008, but a mathematician would read this as 8. And because that 8 is in the thousandths place, 8 thousandths of a cubic meter, okay? It has a volume of 8 thousandths of a cubic meter. What is the side length of the cube? Let me just write that down, 8 thousandths of a cubic meter. Okay, so we know the volume of this particular cube. We know how much space is within this 3D shape. That's what volume is, like how much space to fill up a 3D shape. But we don't know the side length of the cube. And this is a tricky problem. Let's start by drawing a cube. So what is a cube? Well, it reminds me of a square. So I'm going to start with a square, a little four-dimensional shape that is the same dimension going out. It is the same length, that's what I mean by that, as it is going that way. So square has the same dimension going both ways. But that's just a 2D shape. So a cube is like a square, but it's 3D, and it has that same third dimension going out in the third direction here. And so what I end up with is I end up with this like square box that has an equal side length no matter which direction I go. An equal side length no matter which direction I go. Now, problem here is that I don't know what that side length is. I'm trying to figure it out. But I do know something. I know the volume of this box, how much it holds. The volume is equal to 0.008 or 8 thousandths of a cubic meter. Okay, so that means if you took, well, actually, hold on. I was about to go off on a tangent. I won't, though. I'll stay right here with you. So that's how much it holds, which is not very much. So this must be a small cube. But the question is, what's the side length? So if you went to your GED formula sheet right now, it would kind of fail you. You would be like, what am I going to do? Because if you look in the volume section, there is no cube listed there. None of the volume formulas say cube. Now, some students do understand, well, a cube is a type of a rectangular prism. A cube is a type of rectangular prism or solid. So they go, okay, well, I'll bust out that formula. And they're right. There's nothing wrong with that. And that says the volume is equal to the length times the width times the height. Basically, if you want to find the volume of a box, any kind of square or rectangular box, you just multiply together the three dimensions. The length, the width, and the height get multiplied together. Okay, so what that means is that this volume here that I know was found by multiplying together three numbers. And I don't know what those three numbers are, but I do know one thing. They're all the same. Can I say that again? They're all the same. If this one is 5, then this one is also 5, and this one is also 5. But I don't think they're 5, because 5 wouldn't have given me such ugly numbers. So if this one is, 1/2, then this one is also 1/2, and this one is also 1/2. Okay, so that's what it means for it to be a cube. All three dimensions are the same. So watch me rewrite this formula. This is what I'm going to say. I'm going to call this side length S. Oh, maybe call it E. It doesn't matter what you call it, okay? But this is what I realized. Whatever this one is, whether it's E or M or P or 7, this one is the same thing. So if that one's E, that one's E, and that one's E. So the volume of this shape would be found by like multiplying the three edges together. That's just the same thing, 1, 2, 3, multiplying by itself 3 times. We say V is equal to E cubed. I hope you guys know that exponents are used to talk about repeated multiplication. If the same letter, E in this case, is multiplying by itself 3 times, that's like V is equal to E cubed. And now I actually have a shot at solving this thing. Let me show you what I mean. If the volume is equal to the edge cubed and I know the volume, I can plug that into the formula there that I've made, that I've adapted for my uses. Now, you might say, oh my gosh, Kate, I don't know how to solve a formula like this. I think you might, okay? So I'm looking to get E alone. So I know how long the edge is, or the side length is. In order to do that, I'm going to have to get rid of this 3, okay? Now, a lot of students know the opposite of add is subtract. The opposite of multiply is divide, but you guys often forget about the opposite of powers. So the opposite of a power, like the second power, the square, is its root, like the square root. So you say, well, what's the opposite of the cube or the third power? It's the cube root, also known as the third root. So it looks just like the same as a square root, except it has a little 3 tucked into its check mark. Okay, so that's what I'm going to do in order to get rid of this cube. I am going to take the cube root of this number. Now you say, Kate, really, can I just do that if I want to? You sure can, as long as you do it to the other side as well. So we can do whatever we want to an equation as long as we do it to both sides. And now let's see what our new equation will be. Well, cubing and cube root cancel because they're opposites. The E is alone, just like I wanted. I'm solving the mystery of what the edge or side length is. And now I can take the cube root of this long, ugly number in my TI. Okay, now you say, Kate, really, can you do that in your TI? You sure can, but you have to know how, okay? In order to do cube root, you are first going to need to type 3. So type the 3. You need to type the number that's in this little check mark. They call that the index, okay? And then you need, instead of the square root button, you need what's known as the X root button. And that is right above the caret. So right above the caret, oh, let me leave myself some space, actually. Right above the caret, you're going to see this X root button. That's the one you need, but notice it's in green. So anytime you want something in green, you're going to have to hit second. So we're going to hit 3, then second, then the little caret, which will give me the X root, and then you can type in your number 8 thousandths and press enter. And something interesting is going to happen, something that students don't expect. You're going to get something bigger. Indeed, we get 0.2. 0.2 what? 0.2 meters. Okay, so that is the final answer. How long is this edge length? It's 2/10 of a meter. But what students don't understand is they're like, how come if you multiply 0.2 by itself and you keep multiplying it gets smaller and smaller? So hopefully you've seen that before, that when you multiply decimals, decimal places accumulate. But let me just put this answer back on our cube to demonstrate to you what I mean. So here's my little cube. And if I'm saying that the edge length is 0.2, then that means it's 0.2 this way, or 2/10 that way, 0.2 that way, and 0.2 that way. It's 0.2 going out in all 3 dimensions. If I wanted to find the volume of this sucker, I'd have to multiply 0.2 by itself 3 times. And that's the same if you think about it as taking 0.2 and cubing it like we pictured it before. Okay, but what's going to happen when I do 0.2 times 0.2? Well, when we multiply, you can feel free to multiply decimals in your head, like 2 times 2 is 4. Whoops. But please do realize that decimal places accumulate. So if I have 1 decimal place here, 1 decimal place there, I'm going to get 0.04. So 2/10 times 2/10 is 4/100. Now to multiply that by another 0.2, again, you can feel free to multiply in your head. You can just multiply 4 and 2 is 8, but you're going to have to accumulate the decimal places. 1, 2 in this number, another decimal place 3 in that number, and I get 0.008 or 8 thousandths. Each time I take a small number, something less than 1, and multiply it by another small number, something less than 1, my number just keeps getting smaller and smaller and smaller. So that's how my volume got so tiny on a problem like this. All right, so that was a lot of side talk to tell you that, but what was the side length of the cube? The side length of the cube really was 0.2 meters. And I am done. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.